detects if a toddler has fallen into a pool. And so when we're setting up this, we use an RCD weatherproof box, so that it would protect the main current coming through in the water from getting in and electrocuting. So I'll show you how it works. So when the alarm goes off, this will constantly go on until someone who has a key, which is a magnet, passes it back to it and it stops. And sometimes since there's ripples being made, it will continuously make the alarm go off. I'll leave it there. So if you leave it there, it will stop. So the way it works is that here's the value of this is the value coming in from the accelerometer, and so this is a wave of someone falling in, and so A is 1,000 readings turned into a rolling average, B same thing, and C vice versa. So with those three readings, it checks if B is greater than A and C is greater than B. But in the recent, when we changed it now, it's B is greater than A and C the difference. So there has to be a great enough distance between those two and those two. So it has to be a big enough wave. And so this method enables us so that when a wave comes in, that's this, really short, it'll do A here, B here, and C down there, and C isn't greater than B, so it won't set the alarm off. So any really wind kind of splashes won't set it off. So this is how it works. So in this part of the video, I'm going to show how the code for the Raspberry Pi Smart Pool Alarm works. So just to mention, from out here to there was copied off a website. It was about how to connect an accelerometer to a Raspberry Pi, but I added other things to it to fit my purpose. If we go down, there's a startup. Then we have, we're setting up the interval, which is the third of the wave period. The amplitude, which is the height of the wave or ripple. And we both set these to 100 because 1,000 was too long, and it was just making it a really long one. It wasn't that good. So, and with all the other numbers we tried, it didn't work as well. So we stuck to 100. And with the rolling average length, the rolling average concept was mentioned to us by one of my mentors, Jed. He programmed some of the rolling average stuff for me, and so the reason we needed rolling average was because the accelerometer was so sensitive. There was a lot of noise coming through, so we had to filter that out using rolling average. So here we set, ABC rolling average to 0, start up. So then we have a while true, a loop. Here we have an accelerometer Z, and we read the accelerometer 100 times. Then we make a rolling average out of that. Then here we read the accelerometer 100 times and make a rolling average out of that. And then again, in this part, we read it again, the center again, and 100 times, and turn that into a rolling average. So A, B, and C. So on this picture, it corresponds to A, B, C. So then after that's done, it will make a difference. So difference 1 is the difference between rolling average B and A. So then there's difference 2, which is rolling average C and B, so between there. And so then down here, what we check is if difference 1, B and A, is greater than 100 or amplitude. So if it's greater, that means, well, the difference is greater, that means that it's rising. Then we do it again with C and B. So if B is like greater than A and C is greater than B, you know that there's a rising edge along there. So when that's true, so when it finds that there's a leading edge quite big enough, it will set off the alarm, and it will set the alarm to go until someone with the magnetic key turns it off. So then down here is the code for this is the resetting code. So if you look through the code, there's text in red, and that was comments and some of the things we changed, and we wanted to see the difference and things like that. This is the code for my Raspberry Pi smart pool alarm.
In this part of the video, I'm going to show a close-up of the Raspberry Pi smart pool alarm. So first we'll look at the cage, which was built by me and my technology teacher, and is rust proof. So we have perspex there to hook onto the side of the pool. Inside we have a plastic container which has a dead weight and the accelerometer, and that is completely waterproof. So we have wires coming out from there into the GPIO headers of the Raspberry Pi. This box is splash proof, and that is because we wanted to, in case some connection broke, we could remove wires and these cables. We didn't want hot glue. So this is just splash proof at the moment. So the signals come in to the GPIO, and then they come out and go straight to a transistor. And so when that gets connected, this turns on, and the LED. We also have a reed switch really close to the plastic box, and so that's if anyone has a magnetic key, they can close the switch, which will stop the alarm. So I'm going to do a quick demonstration. So if this is wind, so wind, and then a child. So it goes. So then that sets it off. Someone with the key can turn it off. So there is a lot of room for development in this project, as this is the proof of concept. There's a Wi-Fi chip, so you can have it connect to the internet. We could remove the keyboard, mouse, monitor, and make this completely waterproof. Make this and the cage more compact and able to fit any size pool. So I hope this is what you're looking for.